Welcome everyone. This is the friendly stuff of RelNet Technologies, and today we are unboxing SSH Technologies NQX demo kit, which is a quantum encryption solution. First, let me tell you a little bit about SSH. SSH is the inventor of the SSH protocol, which helps you secure the internet for 30 years now. And SSH is mostly known for its privileged access management solution, PrivX. And parallel to this product, they have developed in the past years a solution for securing communication channels with a quantum safe way. And they have created a demo kit which they have shared with us. And today we are going to look into this demo kit, what it does, what it's used for, and we will see the details and we will actually feel it in our hands. So before we open the boxes, let's talk a little bit about why we are talking about quantum safety and what is the thing called quantum threat. Before all, I recommend you to look at our colleagues Nandor Oros's presentation on our e-learning system, and also can be found on YouTube, which explains in a very user-friendly way the basics of quantum safety and the quantum threat. If you want to hear it in a very small nutshell, basically there are two ways currently that allows communication channels to be secured with quantum safe methods. The first is a hardware-based solution. This is very expensive. The other solution is a software-based solution, much easier and faster and less costly to deploy. This is the solution which we are looking at today. It's called PQC, post-quantum cryptography. Basically, it replaces the encryption in the standard communication channels with an encryption that is capable of protecting against quantum computers. Why is it important? Because, as you might know, quantum computers are on a rise. They are very fastly developing, and quantum computers, by design, allow all the current certificates and security algorithms to be cracked very easily. So, in very short time, in only a few years, there will be no currently used encryption standards that will be a match for the quantum computers. So, in order to prepare for that threat, we need to replace the encryption of the current communication channels with a quantum safe encryption. And this is what this product is about. Basically, this allows us for the communication to be encrypted today by using quantum safe algorithms. Why is it important? Because hackers will download the encrypted data today, store it, as long as they have the capacity for the quantum computers to break that encryption, and they will access the data. It can happen in only 2-3 years, and many data that we use today will be still valid in 2-3 years. So this is actually the nutshell what is called quantum threat. And to address this threat, SSH developed the product NQX. This will help to secure the communication between 2 points with quantum algorithms. And basically, that's what we are showing today. There are 2 devices in these 2 boxes, which will be responsible for encrypting the data between the 2 points. And there will be a management console in the middle in the small box. So basically, I would say, let's open the boxes. Layers of security. Yep. And the last box. Let's open the boxes. Now that we have opened the boxes, Gergely will explain what they can be used for. Gergely, please.
So what we have here is one set of the latest release 3.1 NQX, which is the combination of purpose-built software and hardware from SSH to be used for quantum safe encryption. The kit consists of a cluster manager, which can be said or thought of as the brains of the operation, and two 5170s, which are responsible for doing the actual encryption between two sites. A little bit of history about NQX in general. It was released by SSH in 2021, and its purpose is to provide quantum safe encryption, as László said. It can do layer 2 and layer 3 tunneling, as well as implementing layer 4 firewall filters based on packets, port numbers, IP addresses, and so on. It's also capable of doing BGP, and to achieve all of this, the software runs based on a Linux operating system. Now, in terms of the cluster manager, you basically have a web UI which you can use to configure all of your NQX devices in the cluster. And when it comes to the actual workhorses, they run specifically built stripped down Linux operating system, which utilizes a proprietary IP stack, which runs entirely in user space. What's good about this architecture is that in case there is any kind of update or change needed in the encryption section of the subsystem, you can basically just install a new update, and the algorithms can be like plug and play. You can change them on the fly if the need arises. Yeah, so these are basically the workhorses. This is the brains of the operation. This kit is made, or the software I should say, is made in the EU, and it has been certified by the Finnish national security authority for TL level 3, which is EU confidential. So it also has a EU certification, which is always nice. Now, regarding the architecture itself, it's a master worker architecture, as I've said. The cluster manager is responsible for all the network policies that you implement. Also, it handles the node definitions, user management, it's also a certificate authority, and of course, configuration management on the nodes itself. When it comes to the nodes, all they do is enforce the policy that was given to them by the cluster manager. The two parts are constantly in connection with each other using TLS 1.3 with 8,192 bits of key length. So it by itself can also be thought at this point as being quantum safe, because quantum computers are set to be able to bring 2K long RSA keys within the next couple of years, the foreseeable future. So 8K key length is still considered good. In terms of how the traffic is passed along in these quantum safe tunnels, the nodes are using standard IPEv2 key exchange, which is turbocharged, or so to say, or enhanced by using quantum safe algorithms to do the encryption itself. And also what's quite unique about these units is that they have the feature called PPK, or post-quantum pre-shared keys, which in fact is open. The implementation is open. You can see RFC 8784 to dig a little bit deeper about how this works, but basically what it does is that during phase 1 of the IKE2 key exchange, they add an additional secret to the mixture, which comes from a shared list of secrets. Now, the way this happens is that when you install one of these, you have to have a USB drive with a purposefully built image, which can be done from the cluster manager. And during the image building process, you can specify a specific list of pre-shared keys that will be put onto the encryption units themselves. And during the key exchange, all they do is say, let's use for the PPK item number 37 on the list. And that way, because both of them have the same identical list, they can just assume that the other person, the other unit, has the same key, and they can do the key exchange part and the secret generation based on only the index number of the specific key. So the key doesn't traverse the network at all, nor during the initial installation, and nor afterwards. In case of you need to rekey or change keys, they are rolled out to these units from the cluster manager during via that TLS 1.3 encrypted channel with 8K RSA key length. So when the new list is pushed onto the nodes themselves, it's also considered quantum safe. Now when it comes to the cluster manager, this can be either standalone or they can be run in a high availability mode. For that you will need to have 3 of the management nodes. They also have either built-in database, or they can be connected to an external database system, which can be standalone or highly available as well. Other encryption or tunneling options include, you can use certificate-based identification for the nodes. They can also have traditional pre-shared keys, which is, not very quantum safe per se, but the option is there. And you have the choice of either ECDH or the new ML-CAM algorithms for encryption, which are considered quantum safe at the moment. In terms of the ECDH, they can also have 8K or 16K key length. So, yeah, in terms of the physical properties, these nodes have dual redundant power supplies. They also have 4 10 gigabit SFP cages with the appropriate transceivers, and they also have 4 gigabit Ethernet ports that can be used. And for the cluster manager, you have 6 1 gigabit Ethernet ports, and also you have a serial console in form of an RJ45. You also have your standard HDMI.
To sum it up, we visited the SSH Partner Summit in Prague this spring, and we were told that RelNet, after the Nordic, has the most knowledge of quantum safety, which we are very glad to hear, and we also would like to encourage you to contact us if you need quantum safe encryption in your infrastructure. These systems are not deployed in one day to another. It will take some time for the discussions, for the planning, for the implementation, so consider that and contact us. We are ready to help serve your needs. Thanks for watching.
Thanks for watching.
See you later. Bye.